Electrical codes do not permit tapping off the line side of a fan disconnect to supply power to a receptacle. The fundamental reason for this prohibition lies in the intended function of the fan disconnect, which is to completely isolate the fan from all sources of electrical power. This isolation is crucial for safety during maintenance, repairs, or any other situation where personnel might interact with the fan's electrical components. If a receptacle were to be connected to the line side of the disconnect, it would remain energized even when the disconnect is in the open or off position. This creates a significant safety hazard. Individuals working on or near the fan, expecting it to be de-energized due to the open disconnect, could inadvertently come into contact with live electrical parts through the always-on receptacle. This could result in electric shock, arc flash, or other electrical injuries. Moreover, such a configuration violates the basic principles of electrical safety and the intent of the National Electrical Code, specifically Article 210.63, which addresses receptacle requirements for servicing HVAC equipment. This section mandates the installation of a readily accessible receptacle outlet at or near the HVAC equipment to facilitate servicing. However, it does not authorize the use of a line-side tap from the equipment's disconnect switch to power the receptacle. The primary purpose of the service receptacle near HVAC equipment is to provide a convenient and safe power source for tools and test equipment during maintenance and repair. This receptacle should be powered from a separate, properly protected branch circuit, independent of the HVAC equipment's power supply. This ensures that the receptacle remains functional even when the HVAC equipment is de-energized for service. The requirement for a service receptacle within 25 feet of HVAC equipment is in place to promote safe and efficient maintenance practices. It eliminates the need for technicians to run long extension cords, which can create tripping hazards and potentially overload circuits. By having a dedicated receptacle nearby, technicians can easily access power for their tools and equipment without compromising safety. Understanding the correct and safe methods for installing and powering service receptacles near HVAC equipment is crucial for electrical professionals. It is essential to adhere to the National Electrical Code and other relevant safety standards to prevent electrical hazards and ensure the safety of personnel working on or near electrical equipment. Firstly, the receptacle should be supplied by a dedicated branch circuit. This means that the receptacle should have its own circuit breaker in the electrical panel, separate from the circuit breaker that supplies power to the fan or other HVAC equipment. Secondly, the branch circuit supplying the receptacle must be properly sized and protected. The circuit breaker should be rated to handle the expected load of the tools and equipment that will be plugged into the receptacle. Additionally, the wiring and other components of the branch circuit must be appropriately sized for the circuit's ampacity. Thirdly, the receptacle should be installed in a readily accessible location. This means that the receptacle should be located where it can be easily reached without having to climb over obstacles or move equipment. The receptacle should also be installed in a weatherproof enclosure if it is located outdoors. Fourthly, the receptacle should be GFCI protected. A ground fault circuit interrupter, or GFCI, is a safety device that can detect ground faults and quickly interrupt the flow of electricity, preventing electric shock. GFCI protection is required for receptacles installed in wet or damp locations such as outdoors or in bathrooms. Fifthly, all electrical work should be performed by a qualified electrician. Electrical work can be dangerous, and it is important to have it done by someone who is trained and experienced. A qualified electrician will be able to ensure that the electrical work is done safely and in accordance with all applicable codes and regulations. Consider the following example. Suppose you have a 120 volts, 20 amps rooftop fan that you need to power, and you also want to provide a convenient receptacle within 25 feet of the fan. You might be tempted to tap off the line side of the fan disconnect to power the receptacle. However, as explained above, this is not permitted by electrical codes. Instead, you should run a separate branch circuit from the electrical panel to the receptacle. This branch circuit should be properly sized and protected, and the receptacle should be installed in a readily accessible location and GFCI protected. The use of a line-side tap from the fan disconnect to power a receptacle presents a range of potential hazards and code violations that must be carefully considered and avoided. These hazards extend beyond the immediate risk of electrical shock and can compromise the overall safety and reliability of the electrical system. One major concern is the potential for overloading the circuit. The fan disconnect and its associated wiring are designed to handle the specific current requirements of the fan motor. Tapping into the circuit to supply additional power to a receptacle introduces the possibility of exceeding the circuit's capacity, particularly if high draw equipment is plugged into the receptacle. An overloaded circuit can lead to overheating of wires and components, increasing the risk of fire. Another significant issue is the potential for voltage drop. When a receptacle is powered from a line-side tap, the added load can cause a drop in voltage of the receptacle. This voltage drop can affect the performance of equipment plugged into the receptacle, causing it to operate inefficiently or even malfunction. Additionally, voltage drop can damage sensitive electronic equipment. Furthermore, tapping into the line side of the fan disconnect can create confusion and increase the risk of accidental disconnection. If someone unfamiliar with the electrical system opens the disconnect, they may not realize that the receptacle is still energized, leading to potentially dangerous situations. To avoid these hazards and ensure compliance with electrical codes, it is essential to follow proper wiring practices and utilize approved methods for powering receptacles near HVAC equipment. This includes running a dedicated branch circuit from the electrical panel to the receptacle, using appropriately sized wiring and overcurrent protection, and installing the receptacle in a safe and accessible location. The electrical code mandates specific requirements for wiring and overcurrent protection to ensure the safety and reliability of electrical systems. These requirements are designed to prevent electrical hazards such as fire, shock, and arc flash. Firstly, wiring must be properly sized for the intended load. The size of the wire is determined by its ampacity, which is the maximum amount of current it can safely carry. Electrical codes specify the minimum wire size for different ampacities, based on factors such as the type of wire, its insulation, and the ambient temperature. Secondly, overcurrent protection must be provided to protect wiring and equipment from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds a safe level. The rating of the overcurrent protection device must be appropriate for the ampacity of the wiring and the equipment it protects. Thirdly, wiring must be properly installed and supported. Wiring must be installed in accordance with electrical codes and manufacturer's instructions. It must be supported to prevent sagging, damage, and accidental contact with other objects. Fourthly, wiring must be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Grounding systems must be installed in accordance with electrical codes and must be properly maintained. Fifthly, wiring must be protected from physical damage. Wiring must be protected from physical damage by conduit, raceway, or other means. The type of protection required depends on the location and the type of wiring. Regular inspection and maintenance of electrical systems are essential to ensure their continued safety and reliability. Inspections should be performed by qualified electricians and should include a thorough examination of wiring, overcurrent protection devices, grounding systems, and other components. Maintenance should include cleaning, tightening connections, and replacing worn or damaged parts. Tapping the line side of a fan disconnect to power a receptacle not only violates code requirements but also introduces potential risks associated with unauthorized modifications. Unauthorized modifications to electrical systems can compromise their safety and reliability, leading to a variety of problems. One major concern is the potential for using incorrect wiring or components. When modifications are made without proper knowledge or expertise, there is a risk of using wiring or components that are not rated for the intended load or application. This can lead to overheating, electrical fires, and equipment failure. Another issue is the potential for improper wiring techniques. Incorrect wiring techniques can create hazards such as loose connections, exposed conductors, and improper grounding. These hazards can increase the risk of electrical shock, arc flash, and other electrical injuries. Furthermore, unauthorized modifications can void warranties and insurance coverage. If an electrical system is modified without the approval of the manufacturer or the insurance company, any warranties or insurance policies may be voided, leaving the owner responsible for any damages or liabilities. To avoid these risks, it is essential to obtain proper permits and approvals before making any modifications to electrical systems. Permits and approvals ensure that the modifications are reviewed by qualified professionals and that they comply with all applicable codes and regulations. Additionally, it is important to use qualified electricians for all electrical work. Qualified electricians have the training and experience to perform electrical work safely and correctly, and they are familiar with all applicable codes and regulations. The National Electrical Code, commonly referred to as the NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions as the basis for their electrical codes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It provides detailed requirements for the safe installation of electrical systems in residential, commercial, and industrial buildings. The NEC is not law, but it is widely recognized as the authoritative source for electrical safety standards. Many jurisdictions adopt the NEC as their electrical code, either in its entirety or with modifications. Compliance with the NEC is essential for ensuring the safety of electrical systems and protecting people and property from electrical hazards. The NEC is updated every 3 years to reflect changes in technology and best practices. The latest edition of the NEC should always be consulted when designing and installing electrical systems. In addition to the NEC, other standards and regulations may apply to electrical installations depending on the location and the type of installation. These standards and regulations may be issued by federal, state, or local authorities. It is important to be familiar with all applicable standards and regulations before beginning any electrical work. In conclusion, it is not permissible to tap off the line side of a fan disconnect to power a receptacle due to safety concerns and code violations. Instead, a separate, properly protected branch circuit should be run to the receptacle, ensuring compliance with electrical codes and promoting safe and reliable operation.